Hello everyone. So today we are solving another question of JEE ADV 2070. This is on the topic of ray optics. So let's first read the question. They are given a monochromatic light which is traveling in a medium of refracting this eta equal to 1.6. It enters stack of glass layers and like all the time refraction is happening here. And the incident angle is given as 30 degree. The interface of the glass and layers are parallel to each other. The refractive indices of the so there are actually m slabs or the m different layers of different refractive index here. So we have to tell what is the value of m. Okay, so how many slabs are there, because they are changing by some delta nl. Okay, so this question seems pretty hard, but if you like write all the equations or the solutions, then you will get this seem to be very easy here, because you know that if we have a like number of slabs here, okay, and a single ray is only coming like this, and after a many deflection and refraction it emerges out, so we can directly put the like Snell's law over these two surfaces. But I will show you the proof of this, how it comes. So let's suppose let me zoom in the diagram. So let's suppose this is the surface here. What is the Snell's law equation that I will write it for you? Okay. So let's write it theta1, and if the angle refractive here is like, if you know this will also be theta1, and the refractive angle will be now theta2. Okay, so similarly, if I like write for all the surfaces theta1, theta2, so what will be the equation that I will be writing here for the first surface? Okay, it will be nothing but eta1, or the air like what is the uh, refracting index of air is 1 times sine theta into it is given as 1.6, I guess, not 1 here. 1.6 times sine theta is equal to some angle that it will have, so sine theta 1 into n minus point, okay, n minus delta n actually. N minus delta n will be here times the sine of theta 1. Similarly, if I write this for this surface, we will get sine theta 1 times the what is this was like whatever the refractive index of n minus delta n should be equal to sine theta 2. So similarly, if I write it many times, what I will get that all these are equal, and the ultimate equation that I can write from all this will be the equation that I'll be using to solve this equation. So it will be nothing but n1, that is our like refracting index of the surface, that is n times what is sine of incidence. Sine I is sine 30. This should be equal to the outer one, that is n minus m times delta n into sine 90, because you can see the angle of refraction here is 90 degree. Okay, this is the angle of refraction. So this is the only equation that we have to use here, not the complete everywhere we have to solve and solve. So you will get all those as equal, and we can do the calculation. Okay, so let's put the values here. What is n given? N given as 1.6. What is sine 30? Sine 30 is nothing but 1 by 2. N minus m delta 1. What is n? 1.6 times 1.6. Sine 90 is nothing but 1. So 0.1 m here. If I take this that side, so we will get minus 0.8 is equal to minus 0.1 m. So removing minus, dividing it here, so m is equal to nothing but 8. So there are actually 8 slabs. This was very pretty easy question to solve if you know the concept that we can directly put Snell's law over these two surfaces by neglecting all the surfaces inside. So we got our final answer 8. Thank you everyone.